So now I'll focus on the RCA, and then my colleagues will, my colleague Niranjan will explain inline analytics, and then Surendra will explain the SLA monitoring section. So root cause analysis is one of the most time-consuming aspects of a network manager's life. You know, whenever a problem occurred, what happened, why it occurred, troubleshooting, all that stuff. And why that is happening, what is driving that, and what is Broadcom doing to help that, I will explain. So as we saw, there is a lot of noise happening in the network, too much data being collected from too many tools, topological data, logs data, time series data, lots of data collected from the network in today's tools. And there are various sources of that telemetry, like a network, like Broadcom Silicon and operating system export some data. They collect from the VMs and servers. They collect from the user database. So all this data collected is creating a lot of noise in the network. And as we know, there are a lot of false positives. That means too many false alarms, too many false tickets. So that is resulting in wasted time and misuse of the expert resources. As RCA takes longer time, the ticket moves from L1 team to L2 team to level 3 team, right? We are familiar with that, and that means as more and more domain experts get involved, the more cost of IT goes up, and that kind of impacts the operator's bottom line. So the packet drops, right? Packet drops that happens all the time in the network. Packet drops and analyzing why applications are experiencing latency are the two key areas that network managers are facing today. So I'll explain how Broadcom is addressing those issues. First of all, why packet drops matter? This is actually one of my favorite topics because almost all my customers are very much interested in understanding how we provide visibility into packet drops. Typically, there are a lot of hops in a network between the user and the application. And these hops can be a network switch, can be a load balancer, it can be a firewall, nodes like that. And when packets go through all these hops, for various reasons, they get dropped. So, and when these packets get dropped, they directly impact the application experience. If you are, if you're doing a shopping on e-commerce website, then that will freeze. If it is a voice over application, voice over IP application, then you will hear some distortion. If it is a video application, it will buffer because it has to retransmit all those dropped packets, and then the application can provide that service. So that will impact negatively impact the application. And there are various packet drop reasons. Sometimes there will be protocol issues, like there is no destination for a TTL failures, and there could be sometimes misconfiguration, like let's say a particular VLAN was misconfigured, then the packet get dropped because of that. Security attacks is another key issue. Whenever there are certain inbuilt security mechanisms inside the switch, and whenever they detect those, they drop those packets. It is important that the network management station system aware of those so that they can take preventive or reactive actions. And congestion is another scenario, right? A lot of the times what happens, these packets, due to dynamic workloads, congestion happens and packets get dropped because of that, and that will affect the application experience as well. So the mirror on drop, I may be using mirror on drop MOD interchangeably, but MOD reduces RCA. Let me explain you by taking an example. Let's say somebody misconfigured VLAN. So how does that get root caused in today's networks? You wait for the user to complain. Maybe they will call somebody or they will file a ticket. And then the support staff look at various log files and dashboards, whatnot. And they have to go through a lot of data, right? As we discussed, there is too much data collected from the network. So they have to go through a lot of codes, a lot of logs, etc., analyze them. And then whatever clues they find, they have to map to see whether that is what impacting the application. Is that impacting the user? Which systems are getting impacted? And by the way, what caused that change? So it's a long drawn process. And it can go up days or even weeks, consuming a lot of precious resources from the enterprise. How does that get changed with BroadView Plus, specifically with the MOD feature? Mirror on drop sends out a report, a dropped packet in real time, meaning as and when the packet gets dropped, a copy goes to the application, along with the drop reason. Hey, here is the packet that was dropped, so that you have all the header information. And this is the reason why the packet got dropped. That means the application, the monitoring station knows in real time. Because it is providing the insights into why it is getting dropped, and it is providing the header information, the NMS will be able to map that in that case, DX NetOps will be able to quickly analyze, okay, this is a VLAN error. Has the configuration changed recently? And then it will directly take you to the VLAN configuration. So it is just a matter of few clicks. You will know what problem happened, why it happened, who got impacted, and it will directly take to a corrective action as well. So all in all, the MOD feature reduces the RCA from days to just minutes, and that means a lot of savings on the enterprise side. Now I will play a demo. It's a 5-minute demo, and if you have any questions, I will take them after playing the demo. Let me just 1 second.
Let's look at a real-world analogy and how it relates to real-time packet loss notifications and visibility. You're going on a flight but have multiple layovers in your trip. This is like any application flow in an enterprise network. The baggage handler or network switch moves your luggage or packets to the next plane in your trip, or the next switch or hop in the application flow. The baggage handler can remove or lose your luggage for various reasons. Because no one notifies you of this, you won't know until you get to your final destination. Wouldn't it be better if before you reach your final destination that real-time notifications were sent to you for why your luggage was left behind, like the wrong airport code, or it was suspicious looking, or there was no identifying information? Or even get real-time details on where your luggage exactly is, if your bag is broken or if anything is missing inside? Or even the likelihood that other bags you own will also be lost on your trip. Packets may get dropped for various reasons, and Broadcom Silicon can directly send a copy of the dropped packet along with the drop reason to Broadcom's DX NetOps network monitoring solution, or any third-party monitoring tool. In this demo, we're going to look at 3 different use cases where packet loss directly impacts the application experience. We'll show how the Broadcom integrated solution drastically improves root cause analysis and triage times from hours or days down to minutes, with real-time single-click visibility and insights, along with reducing the number of tools needed to be successful. Here we see DX NetOps fault management topology visualization show a degradation on this sonic switch. We instantly understand the infrastructure affected, and with one click, we'll understand the root cause of the issue, along with intelligent insights into specific reasons for the packet loss, along with recommended remediation to quickly restore the application experience. With single-click access to our unified NetOps portal across fault, performance, and flow, let's start troubleshooting these packet loss scenarios. A common packet loss scenario is an erroneous automation job for a deployment configuration which set an invalid ID on a data center switch. Here we have identified a packet with a VLAN ID that doesn't exist on the switch. So of course, these packets are being dropped. Immediate notification of this with descriptive reasons and error codes are presented via the DX NetOps integrated alarm console directly to operations staff. We also give network teams the symptoms of the packet loss, the probable cause, and recommended actions to take to resolve the issue. Integrated topology visualization is always available for enhanced visibility, as well as in-context interface health for granular visibility into utilization, trends, and even discards, saving hours and days of root cause analysis troubleshooting in multiple tool sets like packet sniffers or log analysis, while always helping to preserve SLOs, SLAs, and the application experience. Let's look at a security issue related to packet loss. DX NetOps has detected that the source and IP address are the same, maybe someone trying to attack the network with spoof packets. We can quickly identify security issues with a real-time notification of packet drops where source and destination are the same. Runbook automation can block that IP address and quickly resolve that packet drop scenario, restoring any degradation even before the application experience is impacted or customers are even aware of an issue. Another packet loss use case we support is bad routing issues on the network. Routing issues may cause loops in the network, resulting in packets hitting time-to-live limits. Routing loops are a common issue and very difficult to identify, even with good topology visualization tools. As can be seen, the Broadcom solution provides immediate and valuable information here in the alarm console, like source, destination, protocol, port number, etc., helping us understand the application impact and end-user impact. This common scenario always results in application outages and customer experience issues, or even unnecessary load on the network. In addition to the 3 drop reasons we demonstrated today, Broadcom supports real-time visibility for several types of packet drops, such as MTU mismatch, L2, L3 header errors, parity errors, tunnel errors, and more. So as can be seen, Mirror on Drop enables real-time visibility into packet drops along with the drop reason and other key packet details. Leveraging Mirror on Drop, DX NetOps was able to quickly correlate the packet loss issues to the application and services impacted, leading to a faster root cause analysis. Driven by BroadView Plus telemetry directly exported by the Broadcom silicon, Broadcom solutions deliver the highest scale with best-in-class TCO.
Okay, I do have some questions, several questions. First of all, which switches are using this, and how is this sold as a product?
First of all, that was a demo from Jeremy from our DX NetOps team. Thanks to Jeremy for that demo. Rita, your question. So when you say the switches, right? The Broadcom silicon switches like Strata XGS and Strata DNX, specifically like a Trident 3, Trident 4 devices are supported, and also Strata DNX devices like a Jericho 2, Jericho 2 Plus. That family also supports this feature. So that is from the silicon side. And as I mentioned, DX NetOps is the Broadcom's network management application, and that supports this feature.
So any that are using the Jericho, or which others did you say? Trident?
Trident 3, Trident 4 silicon.
Okay, so that's pretty much everything that's out there.
Yeah. Tomahawk, actually, sorry. Tomahawk as well. Trident 3, Trident 4, Tomahawk 3, Tomahawk 4 silicon also supports this feature.
Okay, because this looks absolutely fantastic.
Thank you.
And then the specific BroadView Plus software, how is that sold?
So the features are supported, like MOD is supported by the silicon. So if you get the silicon and the SDK, that feature is supported. DX NetOps is a separate licensed product. As I mentioned before, you can use DX NetOps, or if you have your own network monitoring system, you can use that data. We share the data format that we export, so you can integrate that with your application.
Okay. So the example you just showed was not, that isn't a piece of software. It's just one potential monitoring tool that could be used based upon the capabilities that you have built into the chipset. Is that correct?
Yeah, the feature is available in the chipset. So it is out there in the market today. And the application, the network monitoring application system is, we have one option, DXNetOps. If you want to use another system or your own system, that is also possible.
Excellent. I think, in my opinion, this is really an unsung feature of your chipset. This is the first I'm hearing of it.
Great, thank you.
Question about how you would use this with other applications. If it's, is it sending syslog or something other applications can interpret, or do you need to send it to your product and then have it forward messages, or do some software development?
So this is the silicon itself is sending out IPFix report to a remote collector, right? And if your collector can support IPFix feature, then you can process that data coming out of the silicon. It is not related to syslog. Did I answer your question?
I'm not sure I understood the answer. So what format is it coming in again that other software might already know how to interpret?
It is exporting in IPFix. That's the IETF format, IPFix. And that's the format it exports.
Mm-hmm. Thank you.
So when a packet is dropped, that's when it sends it via IPFix to the collector. Is that what's going on right there?
And we also have the capability. Like sometimes what happens is you may have a large flow hitting that condition, and a lot of packets may get qualified. A lot of packets may be getting dropped. Then we have mechanisms to, process them statefully within the silicon, meaning not to send all the packets to the collector, but only send like the first packet and then inform when the drop stopped. So that kind of capability is also available in our silicon.
Okay, excellent.
A question here. I'm assuming that most of this information is highly dependent upon the network operating system that sits on top, correct? Because I mean, there's got to be, the silicon itself doesn't have any capacity to be able to send data out onto the network to some other third-party collector. So it's got to be somehow enabled by software that sits on top.
Yes and no. Okay. Yes, there is a network OS dependency because you want to configure, saying, hey, you may want to say, here is my flow. Please monitor for dropped packets on this flow. So that's the configuration aspect. It is like a one-time thing that happens, and you go through the network OS. You may want to use the CLI or a REST API to configure that. But that is all the involvement of network OS. Afterwards, it is the silicon. Whenever that condition happening, it is the silicon that is preparing the report and exporting it on the wire. And that's the innovation here. Yes.
That makes complete sense. You're taking it away from the CPU. It's not some third-party feature added on top. It's actually the silicon actually doing the processing,
correct,
which is where all this value comes from. I absolutely get that. My other question, and maybe I'm just missing the piece here. There was a lot of emphasis in your presentation here on root cause analysis and being able to troubleshoot an application. Excuse me. Some sort of deficiency in the application because of what's happening on the wire or at this low level. But I feel like this is just another data point. It's interesting and valuable data, but it's data without context because the silicon isn't aware of the application. It just knows why something was dropped. So is there, when you say that it aids in root cause analysis, how does that mapping happen? Is that something that's dependent upon the user to say, to drive that context, or are you gleaning more information somehow from the information in the packet or sessions? I'm just trying to understand that relationship.
Good question. So actually we are sending with the context, right? When we are sending out the copy of the packet, you are getting all the information, like what is the protocol, what is the application. So as was explained in the DXNetOps tool, the information that is coming from the silicon is good enough for you to map that to an application. And because let's say if I took an example like VLAN misconfiguration, because we are saying, hey, VLAN misconfigured, right? And then we are also identifying what are the flows, or what is the source IP, destination IP, protocol, all those fields. The network management system will be able to automatically map that to impacted application. So we are giving enough context. Yes, we are not saying, hey, these are all the applications directly, but we are giving enough context so that the network management system automatically map that to their application and then potentially take corrective action. In this particular case, it is possible because they know it is the drop code indicates that it is a VLAN, unknown VLAN, misconfigured VLAN. Then they will, they know that a configuration change happened recently, and then they automatically take directly to that configuration so that you can take corrective action.
I'm just interested. This looks like a great technology for end-to-end analytics, and it's really great at the core and data center. But is this something we're going to see go right down to the access layer? Are we going to see this on the 53K products eventually?
I'm not familiar with 53K product, but yes, it is across the CST silicon today. We support in Trident 3, Tomahawk, and Jericho families. And we plan to expand to other devices, enterprise silicon and other devices as well.
Okay, thank you.
Yeah.
And Bhaskar, this is Tony. One of the examples you gave for dropping was possible denial of service, right? It was same source and destination IP address. I feel like that is something that might be policy related. Like maybe I don't care about that. Right? Most devices are destination-based forwarders. And if it has a valid destination IP address, go ahead and forward it anyways, regardless of the source. So you mentioned drop codes. Is there a library of drop codes that you can turn on and turn off on whether you want something dropped or not?
Yes, actually, as we mentioned in the video and I mentioned in the slides, we support a lot of drop codes, whether it is condition, it's kind of dozens and dozens of drop codes that we support. And we provide the flexibility to configure, whatever drop code that you want to enable or disable. It's not that you must configure all of them.
And then, I think I'm just going to kind of piggyback on what Jordan was asking. This is only accessible to us if it's a feature that's enabled in the network operating system that sits on top of the silicon, right?
Yeah, correct. Because that's why, for example, you integrate with that SDK, and yes, that SDK has support already. Broadcom provides SDK, and that SDK has the API defined and everything available. Yes, the network OS need to enable the feature definitely.
Thank you.
But then, if it is not enabled, this feature, you can go and ask your network OS.
Thank you.
All right. So let's move on. Now, I want to address another RCA area before I give it to my colleague. So we discussed about packet drops, the matter of how MOD solves the RCA for packet drops to just minutes. The other area is the application latency. A lot of the times what happens is when an application complains saying, hey, my users are complaining this application is taking more time, the network is the culprit until it is proven otherwise. So that's what some of my customers told me. And I will take a real world use case here. This happened with one of our customers. They are using VDI. This is something that we all use these days. So the VDI is experiencing delays, and they were trying to see what is causing the problem. Is it the network? Again, as I said, network is at fault, right? So they tried to first go through the SNMP dashboards and all the to check if there is any abnormality and check the buffer usage. Are there any packet drops? And logs to see if there are any reboots, etc. Everything looked good, no issues there. Then they tried to do like a trace and ping route, and that did not provide any clue. So they developed some custom scripts to run periodically every day and for a couple of days, and that did not give any clue either. Then they took the last result, that is move the server and storage infrastructure connected to the same switch to eliminate network as the culprit in this issue. And that proved, yes, network is not the issue. So this lasted few days to arrive at just to simply eliminate network as the culprit. If you have the ability to monitor, to understand how long the packet spent at each hop in the network at a packet level granularity for the user packets, then you will quickly eliminate network as a culprit in these kind of situations, right? So that will reduce the RCA time to just minutes. Broadcom's Inband flow analyzer, also known as IFA, is the solution to gain per hop latency. Let me explain with a simple topology, a leaf spine topology. Let's say 2 doors are doors, leaf nodes, and then switch 2, switch 3 are the spine nodes. And in this case, when a packet arrived at switch 1 will add its own metadata. What is that metadata? Like how long when did the packet arrive at that switch? When did the packet leave the switch? What port the packet arrived? What port the packet left? What is the switch ID? Was the port congested at that time? Was the queue congested at that time? So all these details are added to the user packet itself by the switch 1 in the data plane, meaning network OS is not involved. Then when the packet goes to switch 2 adds its own metadata in a cumulative manner. That means when the packet leaves switch 2, there are 2 sets of metadata. One is from switch 1, the second one is from switch 3. And in this particular flow, the last switch is switch 4. So that will add its own metadata. And in addition, it will remove all the metadata added by all the previous hops, create a report, and send to the collector. The original packet, the original user packet, will get forwarded with unmodified for telemetry purposes. And that way, what happens, the application will know in real time how long the packet spent at each hop, what path it has taken, whether the packet experienced any condition or not, and then that reduces the RCA to just a few seconds or few minutes. And that is the feature that we think eliminate this issue for application experience when it comes to latency issues. And more details on this IFA, and also we have a demo that will be presented by my colleague Surendra in the next section. Any questions before I hand it over to Surendra?
Yeah, Bhaskar, this is Tony again. Yeah. When I see on the slide here and here, you talk about modifying packets, or I assume probably modifying the frame. What happens if it's passing through a switch that doesn't know how to read that data or interpret that data? How is that being snuck in there? Again, I assume in the frame, but I'm hoping that the demo will show us. What if this passes through a switch that doesn't support that?
Oh, great question. So so this is an end-to-end telemetry, right? And if the node can support, then only we will gather telemetry from that particular node, right? If it cannot support, then it can pass through that node, but you will not have metadata from that node. And the algorithms that we have provide details to the collector so that the collector will tell you there is a hole. You will not have metadata from that node, but at least it went through 5 hops, and 3 hops have added metadata, but 2 hops did not support. And that's the best we can do, right? Because any new technology, you cannot go back and implement in all the previous silicon.
Got it. Thank you. I just wanted to make sure that this was implemented in a way that when it crosses a switch that doesn't add metadata or doesn't know how to interpret it, that switch doesn't drop the packet or the frame, assuming that it's malformed or something.
Yeah, this is a valid question that even our customers also ask about it, and we have mechanisms to basically make it pass through for those switches. You will not have metadata, but the packets you will be able to process end to end.
So I love that the answer is yes, but I think what we're asking for is what is the mechanism? This is a highly technical crowd. I'd like to know what the mechanism is. Where are you putting that metadata so that when it crosses the next switch that is not one of your switches, it's not being dropped?
So for example, when the switch passes through, then this is the IFA standard. I don't know if you can Google it. there is a public IETF draft that is available on the internet, and this draft explains to exactly the header format. Okay, where exactly we are inserting this metadata and how we are processing. That's first thing. Second thing is, when you are going through these switches that don't process this are not IFA aware, then you need to be able to basically define the rules, user-defined fields, so that you can switch the packets using some additional fields in the packet, so that the packet follows the same path.